Today, we're going to be talking about flat Earth. Now, when confronted with actual pictures of Earth from space, flat earthers say that NASA and other space agencies are a government conspiracy. When you point out how the Russians never contested the moon landing, despite it being in their geopolitical interest to do so, they say the Russians were in on the conspiracy as well. And so are the Chinese and the North Koreans, and it's all one giant world government conspiracy to suppress the truth of the flat Earth. When you provide actual measurements that the Earth curves, like measurements of spherical excess, which prove it beyond a shadow of a reasonable doubt, they claim that science and surveyors are also in on the conspiracy as well. There's only a select number of elite conspirators pulling the strings and manipulating information at the top. And all these witless surveyors and scientists and NASA employees just buy into the big lie and are swindled by these small group of deceivers. And they just can't seem to figure it all out for themselves, despite being extremely credentialed. So today, I wanted to focus on just the evidence that they cannot possibly claim is a conspiracy, that they cannot just explain away, because there are millions of witnesses and every single person watching can verify and test all this for themselves. So my first line of evidence here is one of my favorites, sunsets. So we've all seen a sunset, hopefully. Sunsets are impossible on a flat Earth. I've had numerous flat earthers tell me how they think a sunset happens on a flat Earth, and all of it runs contrary to reality. They talk about the sun shrinking as it gets farther away, and it's how it's really just perspective. But again, perspective, things get smaller and smaller and smaller and closer and closer and closer to the horizon, but they don't get obstructed from the bottom up in a very clear and stark fashion, which happens for the sunset. Here you can see a little time-lapse series of photos where the sun has the exact same angular size as it gets closer and closer to the horizon. It's not getting smaller and farther away. And then right there at the bottom, you can see that it is partially obstructed from the bottom up in a very clear and crisp line. So nothing about angular resolutions or bleeding into the horizon and meshing together, nothing optical, because again, it's a clean and clear and crisp line. And for anyone that doubts it, I really encourage you, go look at a sunset yourself. Don't look at it with your eyes. Look at it with little eclipse glasses. These are like $3 or $4. I got these at a gas station. They're super easy, super cheap. You can do this yourself. Watch it with these glasses or a solar filter on a camera, not an ND filter. ND filters are not the same as solar filters. I see flat earthers trying to push that lie all the time. Use an actual solar filter or a pair of glasses like this, and you will see for yourself that the sun is the same angular size the whole time and is obstructed bottom up. That is flatly impossible on a flat Earth. If my debate opponent tonight, Flatzoid, disagrees with that, I look forward to hearing his explanation for how sunsets are possible on a flat Earth. They only are happening on a globe Earth model. This shows pretty definitively for anyone and everyone who's ever seen a sunset that the Earth is a globe. Next, this is just a very short and fun one. Here is a picture of the moon from the northern hemisphere, and here's one from the southern hemisphere. As you can see, they are reverse images of each other. I would really like an explanation for that. I've never even heard a flat earther try to attempt to explain this one, so I don't know how they think that this happens, but I'd be curious to just hear what the explanation is. I mean, it's the same night, it's the same moon. In the northern hemisphere, you see it one way. In the southern hemisphere, you see it upside down. How does that happen on a flat Earth? It makes total sense on a globe Earth because one person's looking this way, one person's looking this way. At the same moon, you're seeing it from different angles. I mean, it makes total sense on a globe Earth, makes no sense on a flat Earth. So here's the meat and potatoes for this presentation here. Here's a map of the flat Earth. This evidence works on whatever kind of map you use. I know that some flat earthers don't like this map. They prefer another map. Use whatever flat Earth map you like the best. You're going to get the same results. So let's look at a flight, right? Let's look at a flight since my debate opponent tonight, Flatzoid, is from South Africa. Let's look at one from Johannesburg to Sao Paulo, Brazil. Now, This flight, I looked up myself. You can look at it yourself. Look at the price, kind of pricey, but you can get this flight. And here you can see that the flight times going one way is 9 hours and going back the other way is 10 hours. So 9 to 10 hours thereabouts for this flight. Now let's compare it to Johannesburg to Newark, near New York City. This is another nonstop flight. Look on a flat Earth map, they look, roughly the same size. The one to Newark is maybe a little bit smaller. Now, when I look at this flight, though, whoa, that is 14 and a half to 16 hours. That is bizarre, isn't it? Since it should be a lot smaller. Let's compare it to, let's say, Johannesburg to Sydney. Now, that is a really, really long flight on a flat Earth map. I mean, that's the longest. That's basically you're flying around the world. Now, when I look up this flight, the flight times are 12 to 14 hours. So less than the flight to Newark. See, this is not really making much sense, but let's look at one more, right? So you can see along this route that the route passes over China. So let's just stop by in China, like 60% of the way through our flight to Sydney right here. And let's fly to Hong Kong nonstop from Johannesburg. You expect that to take a little bit less than 12 to 14 hours, right? Since clearly on the map, it's only about 60% of the way there. But when you look at the flight, oh, wow, it's 12 and a half to 13 hours. It's actually roughly the same amount of time as the flight to Sydney. Now, each one of these time makes no sense on any flat Earth model. Any single flat Earth map is impossible to make sense or rationalize what these flight times are, why they're like this. However, when you look on a globe, you very quickly understand exactly why all these times are this way. Here's a globe. You can see clearly on the comparison from the flight to New York to the flight to Sao Paulo, it makes complete sense why one is 14 to 16 hours and the other is 9 to 10. It is very easy to see on this map. Likewise, when we compare Hong Kong to Sydney, you can tell why they're roughly the same amount of time because they look about the same distance on the globe. So clearly, these flight times pretty much conclusively throw out any flat Earth model. They render a flat Earth impossible to explain rationally. And again, anyone can look at these flight times. These flights are all around $1,000 each, so it's a little bit more pricey than the eclipse glasses, but you can do this. Flatzoid, you specifically can do this. You live near Johannesburg somewhere. So do these flights. Look out the window. You'll also notice that on the flat Earth map compared to the globe map, they're totally different routes. You see that the flight to Hong Kong passes over Madagascar. So when you do this flight, Flatzoid, look out the window. If you see Madagascar, you know that the Earth is not flat. If you do the flight to Sydney and you don't see Madagascar and you only see ocean the whole way, you know that the Earth is a globe. So it's very easy. Anyone can do this themselves. If you can't afford it, but you have a friend in that area, like I could call Flatzoid, say, hey, look to see if this flight leaves at this time. Then I could check if it arrives at the time it's scheduled for. Very easy. Flight trackers are free. Now, I've heard some people say that there's some jet streams or something, but this is why I looked at going one way and then back, because the jet stream explanation cannot explain why those times are so close to each other, right? If you're just accelerating in some sort of super hyper jet stream in the southern hemisphere, well, that's going to accelerate you one way and then massively drag you on the way back. But the flight times are all pretty close in the same ballpark for northern or southern hemisphere. Jet streams can't explain it. You also can't explain it by saying that, oh, all these corporations just want more money out of people, so they're taking longer routes and they're messing with all the data, because that does not make any sense. For one, we can also track private jets. There are plenty of private jet trackers that are not a corporation. This is the actual owner of the jet trying to conserve as much fuel as possible, and they're taking these same routes. So we know it's not just the corporations price gouging, and it also makes no sense for them to do so because, again, they could charge the same price. If I want to fly from Johannesburg to Hong Kong, I'm going to pay that rate no matter what route they take. I'm paying for it to get to my location. So it makes sense for them to use the shortest possible route to conserve fuel so that they can make the biggest profit possible. It is literally within their profit motive, not to just mess with all of these routes, okay? So how do flat earthers explain this? Here's a popular flat earther here. I know Flatzoid, you have differences with him, so I'm not trying to say that you're going to do the same thing he is, but you can clearly see that this is just a straight up lie. That's how he's explaining this. In his little graphic there, you can see he's illustrated this flight from Dallas to Beijing, and he's saying, look how far away it goes from Calgary, and yet the flight once from Dallas to Beijing made an emergency landing in Calgary, and he's drawn on a flat earth map. But when we look at the real map of the Great Circle route between Dallas and Beijing, we see that it clearly lines up. What'd you say, Ryan? Holy crap. Okay, well, that flat earther was just totally lying. What about the ice wall? You can actually book a flight. This one leaves from November 19th from Melbourne, and you can go to Antarctica. Here's a picture of a guy that did it. Here's the route that they take. It goes along the edge, leaves from Australia. Here is a way more expensive route. The last one was about $2,000. This is $98,000, but you can do it. They take 250 people to the South Pole every single year. The company is called White Desert. You can do it yourself. Here's the route. Here's where you go. This is the actual South Pole. And here's a YouTube video. Everyone can go watch it. This guy did the service from White Desert. It is open to any citizen. If you have $100,000, it's a little out of my price range, but you can go there. And this South Pole proves the Earth is not flat. It's a globe. And thank you.
All right. Well, if anybody was wondering what I was saying to Grayson there, we were just running a little low on time, but we can always revisit this a little bit as we get into it. I'm not too shy on that. Sometimes we follow traditional debate rules. Other times we're a little bit more loosey-goosey. So welcome everybody in the live chat. Glad to see you're all hanging out there. Lots of friendly faces and modern day debate classics hanging out there. Just want to remind everybody, Dallas, Texas is where I'm flying out to tomorrow. Let me know in the live chat where you're hanging out. It's always nice to know where our live audience is, and those tickets for our live event are linked in the description right now. So if you haven't had a chance to check it out, now is the last chance to go and check out both links in the description for our live event. So if you're going to be in the area and you can make it and you want to see these amazing speakers in person, check that out. If you can't be there, you still want to support the channel, super chats are a great way. We got super chats at the end, but we also have our crowdfund linked in the description. So if you check that out, there's a bunch of perks there. This is the last chance to get access to those perks, like a signed emblem of your favorite debater. There's also, you can get a one-on-one with James, or you can get the emblem with a bunch of signatures. So without further ado, no more housekeeping from me. Over to you, Flatzoid, I'll give you an extra minute there on the clock.
Awesome. Thank you very much for coming. Thank you, Base Theory, for joining as well. I really appreciate you coming on. We had a great debate previously, but it's good to be here. Anyway, tonight we're going to be discussing globe versus flat, and I thought he's probably going to present evidence for a globe, but instead he was trying to go against flat Earth. So I'm going to go and give evidence on why it's flat, and then we'll take it from there. But can you guys see my screen? Yeah. Okay. So yeah, thank you guys all for coming. So I'm going to try and keep it down to earth for my opening, as we are discussing the shape of the Earth. So, and just FYI, yeah, flat is not a shape. Okay. Anyway, so I'll open with the horizon, because I want to base this whole argument on why did the globers start in the first place to think it was a globe? So they would say the horizon. We looked out on the ship. We look at ships going over the horizon, so therefore it has to be bottom up, so it has to be a spherical Earth. So I was thinking this would be the perfect segue to say, okay, let's see what the horizon actually is. And if it's optical, which is my argument, which would mean it's not a globe, because you would have to be physically proving it's physical. And since you can't prove the horizon to be physical, you've already lost the debate. So I will move on to that. So what is the definition of horizon? The line at which the Earth's surface and sky appear to meet. The sun rose above the horizon. So this already goes in contention with his sunset. So it's the limit of a person's knowledge, experience, interest, and she wanted it so forth. So it's the range of vision, which is similar, and its field of view. So just noting that it is only an apparent position, so optical. Then we move on to level, because obviously As you know, water seeks its level at rest, and level is very, very specific to a horizontal line. It has to be flat, no curves, no part higher or lower. It is a flat plane, even, smooth, so we'll go into horizontal plane, which is horizon because it stems from horizon, or line, respect to distance above or below a given point, the position of scale, amount, quantity, whatever. Okay, then we just move on to having a flat horizontal surface at the same height as someone else, and blah, blah, give a flat and even surface too. So we understand what level is. The first one I want to go to is the River Nile, which is 6,600 kilometers, or in terms which the Americans understand, 4,100 miles of level water. So if you understand that it's a horizontal plane of 4,100 miles, you would understand that there would be a curve to there. And since there's no curve for 4,100 miles, it shows it not to be a globe. Now you can see the route that they go through the River Nile. It's quite a distance to travel. Then we move on to the same with the Mississippi River. It's showing also 2,340 miles of also just flat, horizontal, level water. And this, again, once again, shows that it cannot be a globe because you would require a curve over that 3,766 kilometer stretch. Next, I would move on to the salt flats. The salt flats in Bolivia would be at the same elevation, 3,900 square miles in area. So it's the world's largest salt flat. Remember, when you're talking about a salt flat, it's called flat for a reason, because it totally goes against a curving surface. Now, I also want to move on, since we're talking about being optical. This is I will show this later, a screenshot taken from Michael Kahn, shout out to you, mate, where he lives in England, and he went to the beach and he took some observation of wind turbines in the distance. Obviously, you're seeing this looks like it's bottom-up obstruction, as you would put on the globe curve, but we're going to show why this is only optical and it cannot work on your globe. Yeah, he's showing his distance. We'll also show the video. Just want to show you all the schematics so he knows exactly which turbines he's looking at and how far they exactly are. The blue, and this was turbine 2 and this was turbine 1. As you can see, the line 2 and 1 to show it's further away. Now, the distances, it shows that they are started 8 kilometers off. So in other words, this whole Linksha wind farm started 8 kilometers off, and each turbine is 500 meters apart. So if you have to put the maths together, the target distance would be enough at 7 miles with the 6 feet observer height. The only target hidden height you would have is 10.6. Well, we can round off to 10.7 feet. The issue is that there was over 61 miles too much curve. Based on the calculations and how much he saw, there was 61 feet too much curve. So in other words, your globe had too much curve. And if you're going to claim it's refraction, it would make it worse for you, because based on the globe refraction, you require it to be making it look flat. So in other words, it would lift it up further and not make it go worse. So that goes against the geometry, and your refraction idea of the optics freeze your globe. And here's another video I'm going to show just now as well. Light refraction at home. This is just a screenshot on the floor again, showing when they open the door, the refraction doesn't bring something over the curve, it causes the optical obstruction. See, as it's going, and there we go, gone, just because of refraction on the flat surface. Then we're also going to get into some focal length talk. This is from the latest from Sean Hawkins, trying to debunk my focal length argument. Here I lined it up, as you can see, to the stop sign and tried to get it as close as possible, even though you can't get it a perfectness, because even he had to manipulate it for the width just to get it to work. You can literally see, based on focal length, the smallest focal length on the left, the wider focal length on the right, they do not align. The one with the right focal length shows it to have compression and parallax, and therefore gives a foreshortening effect, which shows, once again, whenever we look out in the distance, we can explain things using focal length as a perspective thing. And that's my statement. I can give up the rest of my time.
All right, we'll end the screen share there, and we're going to kick it over into an open discussion. Before we do that, everybody, I just want to remind you once again, both of our speakers are linked in the description, and they will be linked in our podcast description as well. So if you like what you're hearing, you can find both our speakers there. I also want to let you guys know we have been sponsored, if you don't see that little sponsor down in the corner there, by Manifold. So it's a place where you can go and you can actually make what you would call basic, I guess, bets on the debates that we're actually going to have coming up and other things that are happening in online spheres and places. So, right now there's what one is up for debate? Let's see here. I'm just going to check with the Manifold right here. You know what? While I check that out, I'm going to pull that up for the end of this discussion. But you guys can check that out in the live. We're doing another screen share, are we?
And I was just teeing it up. But,
it's all good. We're right into it. So yeah, let's go into open discussion, everybody. And thanks for being here, everyone.
Sorry, to kick things off, Flatzoid, can I just show you 3 images? Okay, cool. Well, here is a definition of level from Merriam-Webster's dictionary, conforming to the curvature of the liquid parts of the Earth's surface. So as long as you're showing definitions of level, here's a definition of level that's used in surveying, that literally is conforming to the curvature of Earth's surface. So did you want to comment on that, or should I move on?
Okay. I can challenge you to bring up any definition on the internet that shows curvature of the liquid parts of the Earth's surface. And then I want to let you know, this is not surveying definition. And also got to tell you, you do know that part that they put in curving to the surface contradicts the rest of the definition. If you open the definition, it literally has it in the adjective, a horizontal.
Okay, so you are aware how definitions work, right? Where words can have multiple definitions and some of those can be contradictory to each other. This is not just the word level. There are tons of words that have multiple definitions to the word, and 2 of them mean like total opposite things.
Would you open quick? Would you be kind enough to?
Wait, what?
Would you open the? No, it's fine. You can leave it. Would you open the level definition quickly?
This is just a screenshot. This is just a screenshot.
Okay, then it's fine.
I can move to the next image. I just had 3 images I wanted to show you. This is the first one.
Okay, for now. And then I'm just gonna, once you've done that, I'm also gonna just get the Merriam-Webster then.
Okay.
I want to show you something.
But again, I just want to show, words have multiple definitions, right? You have to use them in their proper context. And if you want, we can, there are literally surveying textbooks that use this definition of the word level in the textbooks. I don't have them on hand, but I can provide those to you after. Anyways, this is nothing mysterious. Words have multiple definitions. This happens all the time. Sometimes those definitions are contradictory, and you have to use them in their proper context. If I was just describing something as level on my desk, that's not the same thing as level on the Earth's curvature. Those are different contexts. That's how all words work. It's not unique. Anyways, next picture.
But I just going to say, based on that topic you just brought up, in the Merriam-Webster definition you brought up, it specifically talks about Earth's surface. So it's in context of Earth's surface. And if you open it, can I share my screen for 2 seconds to show you what I'm talking about before we move on to your laser? If you don't mind.
I'll pass it back over. I feel like there'll be a little bit of this going on, fellas. So don't mind us in the live chat.
You can see this. This is that exact same definition. This is what it says there. Level, flat, plane, even, smooth, meaning having a surface without bends, curves, or irregularities. Level applies to horizontal surface that lies on the line parallel with the horizon. Remember, horizon is a flat horizontal plane. Flat applies to the surface devoid of noticeable curvature, prominences, or depressions. Plane, even, smooth. Now, this is exactly the same definition placed from you. Just like we're saying, were you saying it is now contradicting in another sense? No, it's exactly. B, parallel with the plane of the horizon, horizontal. You do know this conforming to the curvature of Earth is just put in because people's belief of a globe. Now, that's why I say, I challenge you.
That's the definition, man. I don't know what to tell you. That's the definition.
But that's what I'm telling you. I challenge you to bring up any other dictionary, any other definition which shows it to be curving to the liquid parts of the Earth's surface.
But I'm not.
Anyway,
look, you're arguing with the dictionary right now. All right. I mean, come on. That's literally the definition.
No,
just saw it on the dictionary.
you brought it up. You brought the Merriam-Webster
No,
up, so I
you
have to
brought up
rebut it.
the definition of level. I'm just
Yeah.
showing that you left out the definition of level that you disagree with. Okay.
No,
So,
I didn't.
yes,
I
you
just
did.
brought you a definition. You brought up a specific definition which debunks itself by contradicting itself in its own sentence.
That's not how definitions work. Okay. Words have multiple meanings. Anyways, I don't want to get on a whole semantics debate with you. I want to move on to actual evidence here. Look, you said that refraction doesn't cause things to curve like this. Here is an image showing that refraction is causing this straight laser to curve in an arc. All right. The way that refraction works is that the light ray is continuously bent in the direction of the more dense medium. So when you have a density gradient, the light is continually bending as it travels along the Earth's surface. It's continuously bending along that surface towards the more dense medium of air closer to the surface. That's science.
Okay, cool. First of all, we don't look through water. This would be Snell's law, which is
doesn't matter if it's water or air.
Yes, it does. With the refraction, you require Snell's law, which means you require two media with boundaries. Now, I'm still talking, and now you see he's got this laser. Can you see the incident angle he's pointing this laser at? What would happen if he had to bring it and show it level to the tank?
He's pointing it level.
No, he's not. He's pointing it at looks like a 45-degree angle.
Literally, it's bending in an arc. But here.
No,
I want to address what you said already. I want to address what you said already about Snell's law, right? The thing that you need for Snell's law is two different coefficients of refraction. Now, in one medium, in air, if you have different densities of air, as we know happens with a pressure gradient, you're going to have different coefficients of refraction for each one of those pressure gradients. And that's why Snell's law applies in this case. It's the same medium, it's air, it's just changing in density. Thus, the coefficient of refraction is also changing and causing it to curve towards the more dense air closer to the surface. It's provable.
Okay. So it's not provable. First of all, I'm going to tell you, that's not Snell's law. Snell's law requires you to have two different media.
Nope.
If you try... Yes, two different media bring up Snell's law and you can see it for yourself. Anyway, it's got to do
two different coefficients of refraction, which can occur in the same air as long as you have different densities. Those count as different mediums if they have different densities.
Okay, now I'm going to tell you, Snell's law requires an incident angle and a secondary angle based from the incident angle. You would agree with that? So angle what? Incident angle, angle 2. Where is that partition to give the second angle?
Again, it's the partition as the density gradient changes. It's a continuous, like there's not a smooth partition. It's continuous because it's a continuous transition of densities.
Okay, then I'm going to ask you, you got on screen now a fish tank. So it's got a membrane and it's got water, which is obviously he's made denser, putting sugar water or whatever.
Yeah, sugar water.
And the laser is outside. So he's got air, glass, and water.
Yeah.
Is that how we see in reality?
Again, it's bending through the water.
No, your demonstration is not demonstrating light refraction through the Atmos plane because you are showing three different media. And you're claiming it's demonstrating refraction based on Snell's law with media.
Yes.
You're not changing the medium in the Atmo.
But the medium is changing density as a function of height. So that's just a factual piece of information. And I do want to press you on refraction because actually the world record for the longest distance photograph ever taken was done by a glober, by the way, who calculated it based on refraction. So he waited for the refraction. What was that, Ryan?
Okay. Well, we talk about it.
Oh, okay.
We'll come back to it, but just so people can see us on the screen while we're...
Oh, they can't see it? Okay, gotcha.
No, it's all good.
Yeah. So the world record for the longest photograph, like the longest distance photograph ever taken, right, he did it. He got the world record for this by calculating the refraction conditions necessary. He was looking at the weather, continuously updating it, and he waited because he had to hike up to a mountain in order to take this long distance photograph. It's like, you know, an absurd amount of distance. He has the world record. So anything that flat earthers show, oh, this is too long, this doesn't work. This guy, he literally used the globe to do the math and to figure out when he needed to go take this picture based on the refraction conditions. So the math works. You were using the wrong Earth curve calculator. Your Earth curve calculator did not account for refraction.
First of all, that takes standard atmospheric refraction as a given. He took both. He took both our calculators, even the advanced Earth curve calculator, and it showed exactly the same.
But he didn't measure refraction.
Yes. Listen what I'm saying. When you took the other advanced Earth curve calculator from Walter Bislin, it gave exactly the same result because it takes automatically standard refraction into account.
Yeah, but the refraction wasn't standard in the video you're talking about. It wasn't measured.
Again, it gives exactly the same hidden on Walter Bislin's, just as it does in that, because that one doesn't let you change the atmospheric refraction. Walter Bislin lets you change it because it's not based in reality. Now, I told you it gives exactly the same values. Now, I'm going to share my screen again because I want to show you what refraction does in reality when we do actual observations. Now, you claiming refraction lifts up an object. So this is what I love about demonstrations. We can demonstrate this every day, that it takes things away. You see what it's doing to the object? It's causing it to go lower, not higher. Can you explain?
I have no idea what I'm looking at. This image doesn't look like anything.
There's an object. Okay. There's that yellow object. They're going to open the door and it's going to cause refraction, and look how it's going down, away. So in other words, the refraction is causing it to be worse, to make it look like it is curving, not taking your curve away. Notice that this is on the flat surface. They give all the temperatures and heights and everything just so you can see. And this has been demonstrated multiple times. You can do this on practically everything. Many people have demonstrated this.
Yeah, it's been demonstrated.
This goes against your claim that refraction lifts up an object.
It has been demonstrated by the world record photographer, the photographer who holds the world record for the longest distance photograph. He did all the calculations. They're on his website with the photograph. He did the calculations on a spherical Earth model in order to figure out when and where he needed to be to take that photograph and win the world record. So that you're not.
Okay, I'm gonna tell you again. Do you know what a demonstration means? I just showed you demonstration that it does not do the effects you claiming, because he took a photo which debunks the globe, and because he claimed refraction, it actually made it worse for the globe because it shows it is going down, and because we can see it even further because of refraction based on demonstrations that refraction wishes it go down. Therefore, you claiming that it's making it go up is not a demonstration. So I want you to show me a demonstration where it shows it going up.
Every single sentence you just said was wrong, and you need to say the opposite in order to be right, right?
No, I stick by my statement.
And you would stick to being wrong. It's not a surprise.
I just showed a demonstration on screen. I can show many more that give exactly the same effect.
What you showed on screen was like the world's blurriest image. I got no idea what I'm looking at. I didn't see anything, to be frank with you. It would just it didn't look like anything to me. I'm not seeing it. Okay. You need to measure the lapse rate. You need to show that it doesn't make things carry on longer than they would normally. Oh, you also said that the horizon is optical. I would agree. The horizon that we see is visible. That is a part of the globe model. So we're not disagreeing that the horizon that we see is a visible horizon. You don't see the geometric horizon, right? You see the visible horizon, which obviously is going to change based on atmospheric conditions like refraction. This is obvious to everyone. Everyone can agree with this. So yeah, You did that, the definition of level. Then you went to the focal length stuff, and you used the wrong Earth curve calculator as well. Next time, just use Walter Bislin's, and no one will have a problem with you.
Sorry, I got a problem with Walter Bislin's.
Well, that one actually incorporates refraction. So if you
does that one. So does that one. The only difference is Walter Bislin, you can change the value. That one doesn't change the value. It's already got it set in its calculations. Hence why I told you it gives exactly the same value.
Again, in real life, refraction is not idealized. So use the proper Earth curve calculator that you can incorporate the actual measured amount of refraction, which you have not done yet. You haven't. So then if you want to get to the whole focal length thing, because it's really hilarious and anyone can debunk you on that, changing the focal length does not change how much of the image that you can see. It doesn't change any of the proportions. Everyone can just go take a picture with their iPhone, can mess to the 0.5, the zoom, they can mess around with the focal lengths themselves. When you watch a sunset, you're not changing the focal length of your eye at all. You're seeing the sun go below the horizon. Nothing about focal length is changing. And the most hilarious part of all of this, let me just share my screen one last time here. The most hilarious part is that the actual guy whose pictures you were using disagrees with you. He's got these two comments that say, what Flatzoid has failed to recognize is that he wasn't shooting from a tripod. So the exact height of his photos with the two different focal lengths wasn't consistent. He said it's not rocket science, but apparently it's too complicated for a flat earther. So he's coming at you. So you should probably stop using his photographs to try to demonstrate your little focal length shenanigans.
Should I bring up the actual photo which we did analysis on? And then just because I showed him wrong, and you know why he was doing that? Is because of thanks on screen by showing again where's Wally and all globe trolls trolling him. Yeah, trolling him because he was getting bombarded by globe trolls.
So it's all part of the conspiracy.
No, it's not conspiracy. The people are bothering him on his own video, asking him the whole time, were you at the same elevation? Did you change your distance?
Just say yes?
Because he's getting irritated by constant globe trolls coming in saying, we're asking the same question, where he literally says on screen,
Okay, wait. So you trust him when he says something that you agree with, but when he completely tells you to your face that you're wrong, then all of a sudden you can't trust what he says.
Tell me to my face. By the way, I've been watching this guy since they started their channel. Okay, so it's been a few years. He does really good jobs. I got nothing wrong with it. Just because he doesn't understand when he posted his myth of compression and showed compression, I don't have to agree with him because he literally showed compression after he said it's a myth. No. Just because he says it's not so, while we analyze it showing it is so, doesn't make him right because he's the photographer. Okay, I'm going to show you multiple people doing exactly the same thing, trying to debunk me now with multiple different focal lengths, showing you are ignorant to the subject. And by the way, your sun does change angular size. Even NASA says so.
Oh.
No. Okay.
Not significantly. It's a very, very small amount.
I thought you said, so it does change now.
Very, very small amount that has absolutely no bearing on if it was actually getting farther away in order to set on a flat Earth. We would expect way higher amounts. It's not even close, like way more than 6 sigma difference.
Yeah. Okay. This is Andrew Johnson trying to debunk me based on the focal lengths. You see he's got a 30 mil, 26 millimeter, and 65 millimeter.
Okay.
Let's quickly just move on to where he wants to show. Can change it to 2. So let's go where he's placing the bollards. He's trying to show you, and he's trying to say, look, they match up the same. You would say they match up the same, correct?
That looks the same to me.
Great. Okay, let's go when we actually do analysis on this, showing they do not match up at all. Okay,
that literally,
this is one.
That literally looks the same, Flatzoid.
Are all these lines matching up to each other? These are different.
Every viewer can see they are, yeah.
Well, every viewer is then blind. I don't know how you can talk on behalf of a viewer, by the way.
It literally looks identical, man.
Are you smoking something?
No.
This is the bottom of this pole. It's the green line. It's higher than this pole, higher than this pole. This is the purple line for the bottom of this one. It's lower than that one, higher than this one. This is the cyan line for this pole, the bottom. It's lower than both of them. The
Yeah, it looks
tops
the
of
same to
these
me,
lines,
man.
the top
It,
of
it
these
literally
bollards,
looks the same.
the top of these bollards are the same. So it's showing it has stretched and compressed due to the focal length. Now this is just the
Literally,
one
it
guy.
looks the same, man. You're making a joke of yourself.
There, I'm even zooming in and doing action. If anybody wants to see the action analysis, hop to my channel and you can watch me showing analysis on this. So just saying nah doesn't mean it's the
But I mean,
same.
literally, I'm looking at the same thing you are, Flatzoid. They look identical, man.
Again,
You look like you've got like your conspiracy web and all of these connections and stuff, but it's
what
literally like
conspiracy?
it just
What is
looks like a joke.
conspiracy? Sorry. What conspiracy are you talking about?
I'm just saying, you look like the guy who's putting all the things on the wall and being like, look, and there's literally nothing tying them together. Like,
Okay, and then I'm gonna
three of the same image.
And then this is the latest one, which I showed now on my presentation with Sean Hawkins, also trying to debunk me. We should also do a change where he also shows in the different focal lengths. And if you actually do the analysis, you see there's also compression and
Bro, that looks identical.
parallax. Are you smoking something?
That looks the same, man. I think everyone can see that those clearly look like the same
Everyone
image.
can see you just saying no, and you might need to get glasses.
I mean, I got LASIK. I can see fine. That looks totally the same to me. And everybody viewing, I think.
Okay, there's a block. That's the top of that pole there in the focus. Why is it low on the one side?
It's the same.
This was on a tripod.
Man. What are you talking about?
Same position.
Yeah, just put them on top of each other.
This is literally the
You're
larger
literally
focal
just
length.
showing me two of the same image, man. I mean, you know, I was pretty good at those spot the difference games. I'm not spotting any difference here.
So we can say you're being dishonest then if you can't spot the difference. That's drawn on screen with actual lines to show it doesn't match up.
Yeah, well,
Is that stop street higher than that stop street on the left?
Look, like even when you look at the top of the image, you haven't aligned these two images the same. Like when you look at the proportions in each of the image, each of the proportions is the same.
Great. Now
they're the same image. I'm sorry, Flatzoid. I
same image. Okay. Now, if you actually pay attention to my analysis, you'll see I brought it down, lining the two up to the stop sign as their reference, and made them the same size in the stop street. Notice the word stop is still different from the word stop inside there. And every single other thing shows a difference.
Dude, I honestly just think you're making a fool of yourself right now using this argument because they literally look identical.
So in other words, there's no rebuttal to this other than trying to insult me because
there's nothing
blind.
to rebut, man. There literally is nothing to rebut here. You just show me the two of the same images.
Again,
why don't you
one on the left, the one
We've gone through your points. We've gone through your points now.
All you've done is
my points.
You haven't rebutted anything. Yeah. Okay. Cool. First of all, you've done is while it's on screen showing differences. On the right, the larger focal length shows compression and it shows parallax. That's why it doesn't line up perfectly. This is why you do actual analysis and show the lines. Because you say and you may be blind, doesn't take the fact that on screen it shows it not being perfect.
Hey,
okay. And
have you watched
and then
Sean Hawkins' video where he takes these same images from the different focal lengths and he literally puts them on top of each other and shows conclusively that there is no difference? Did you watch that?
You want to go there and where I show him manipulating just the width and not the height.
Oh, now it's a conspiracy.
No,
it's a conspiracy.
I show it on screen. He's only manipulating the width and not the height. I showed this live to many people. So you might not want to trust Sean Hawkins as your arbiter of truth, mate.
I don't trust you as the arbiter of truth either. I got
it on screen.
My eyes are showing there's no difference.
This is Sean Hawkins' video, by the way.
I'm not.
I've done analysis on it. And like I said, if you want, anybody can go to my channel, watch the lives where Sean Hawkins literally
Sure.
only changes
Okay.
the
Well,
aspect ratio of the
Flatzoid,
width, not that. Okay, let's back.
this is
back
not a
to what I
debate
wanted to say.
between you and Sean Hawkins. So why
No,
don't
you
you
brought him
address
up.
the points that I brought up during my opening?
You debating what I brought up, so now I'm allowed to rebut what you are trying to argue against.
I'm
Okay?
asking you to rebut the points I brought up in my opening.
We're still rebutting my things. Can I give my closing statements before
Sure.
we can move on? That's what I was trying to do when you really interrupted me to talk about Sean Hawkins. Okay. So yeah, based on my arguments, the focal length does change what we see. It has been demonstrated even by Dave McKeegan, by Andrew Johnson, by Sean Hawkins, and I can show many other people the same and photography online. If you do analysis, you can see there's definitely compression and parallax. I did a stream the other night with many citations that show my point and explained it and showed demonstration. What we get from the other side is no demonstration, looking at screen saying, no, I don't see it, so therefore you don't. Based on refraction showing, everything shows it going down and not up. And yeah, that's all I need to do on my side right now. Just is all he's got is nah. So what do you want me to debunk on your side, based?
Okay,
because practically everything you said.
I want to encourage everyone, go do this yourself or ask any friend you have who's a photographer about how focal length affects the image. Any professional photographer can tell you that Flatzoid is full of it and completely wrong on this. And you can just do it yourself with your iPhone. Just do it yourself and see for your own eyes. I encourage you to do so. So I brought up sunsets, the moon, and then flight path. So real quick, if we could just quickly, I would like to hear your explanation for the moon. Why is it upside down in the different hemispheres?
Simple. It's just perspective, mate. If you're standing on a different side of the road, you're going to see a different side of the car.
You're going to see it upside down? I've never seen an upside down car based on my perspective.
I didn't say upside down car, did I?
Well, you said
different side, different side, different side. So if you're going to, gonna see if I can, I don't know. Let's, for instance, take
you
this.
see it literally 180 degrees upside down.
Let's see. Let's say this is the moon. Just going to use this as reference for pointing that way. Okay. What happens when you change your view to it? It's going to seem like it's the other side. We've done this many times. You can stick it on your ceiling and you can just walk to the other side and it literally changes the view. It's just location. It's got nothing to do with a globe.
But you understand has been demonstrated. You understand how that's not analogous at all to this situation, right? Because
it can be demonstrated to show it to change when moving location.
Because it's not like you're seeing a different portion or a different angle of the moon. You're seeing all the same amount of the moon being visible. The only difference is that you're seeing it upside down, depending on what hemisphere you're in.
Upside down to what?
Compared to the other hemisphere.
Who's it upside down to?
Comparing the north and the southern hemisphere observers.
So who's upside down? Who's right way up?
It's relative to each other.
So in other words, me in the south sees it at a different orientation based on someone in the north sees it at a different orientation. Location based then.
Yep.
Great. So you can do this with demonstration, like sticking it on your ceiling and just walking around and seeing the location changes the orientation.
Again, but you will never get it to be 180 degrees flipped upside down.
Yes, you can. We've done it many times. It's demonstratable. And just because you say, nah, doesn't stop it from being, dude, you're giving me 2015-year arguments. This stuff has been debunked for years already. Everything you're talking about tonight has actual explanation and demonstrations to it. You're literally bringing a toothpick to a gunfight here.
Well, I don't think you have any actual explanation for this. You're just saying it's perspective, but you can't show how perspective can flip something 180 degrees upside down, unless the only way that can do that is if the observer themselves is flipped 180 degrees upside down, which is what happens on a globe Earth.
Okay, I'm gonna quickly. Great. So you say if we flip it upside down, cool. Okay, let's see if I can quickly share my screen again.
Yeah, no worries about the sharing screen. You guys can share screen as much as you'd like. We still have another, I got 15 minutes on my clock. If you guys want to go a little longer, that's fine. But I will let everybody know, hit the like button if you haven't already in the chat while we get that screen share up. But yeah, just don't leave them on the screen while we're chatting. And basically you were saying something?
Oh, I just want to say I really do want to get to all three of the points I brought up. So if we could just quickly do the moon thing and then sunsets and flight times, and that'd be great.
I agree. Okay. Just for rudimentary focus, we're just going to put this. You can see my screen, correct?
Yeah.
Okay, great. Now, we are standing this side of your moon, looking this way. Which side does that arrow show? Upwards.
Mm-hmm.
Now we move to this side and we look at the moon this way. Which side does that arrow show to us now?
You're literally demonstrating the globe right now.
No. Let me do this way. Let me do this way.
How is it? But look, your two observers, they are completely upside down relative to each other. That can only happen on the globe Earth.
Notice I just drew this flat.
Yeah.
Okay.
How
It's
on a
the
flat
same.
Earth?
It's
How on a flat Earth do you have two observers that are upside down relative?
They're not
to
upside down. This is
They
someone
literally are.
looking.
They're pointing upside down to each other.
This guy is looking to the south. This guy is looking to the north.
Okay.
Okay. Looking to the north, the arrow shows northward. When he's in the south, the arrow is showing still northwards. So it's showing towards him. Get it? Did the moon
What are we
flip
from an
upside
aerial
down?
perspective right now?
It's a bit difficult to draw it. Well,
Yeah.
I can't take my webcam off now and put it on. I can take this and I can stick it on my ceiling, for instance, and I can walk around and I can see this arrow changing position as I'm walking around it. Just like when you see a car drive, let's say you stand at the side of a road and you see a car drive past you left to right. If you go across the road, turn around and look at the other side, that same car coming from the same direction will now be coming not from your right, it will be coming from your left. This is demonstratable. It's just perception based on your location. This is literally things you get taught in primary school.
So the moon is like somewhere in the equator then, and it's facing down.
Straw
and
man.
Two people looking at it from different angles. I'm trying to understand what you're saying.
You're looking at from different angles. Same moon. And by the way, also, it's been observed that the moon does a rotation as it moves around at night.
Okay, so we can move on then to my sunsets one.
Awesome. Sunset is awesome. Like you've also agreed, there is a bit of a angular size change, so that already invalidates that argument.
It does.
Secondly, yes, it does.
It doesn't at all.
Secondly, when we look at the sun, we are looking through more and more atmo, correct? The closer, the further away it goes, the more it seems to drop down to the horizon thanks to perspective, the more atmo we look through.
Sure.
So where there's more refraction, as you put it, based on your argument. No. So when we're looking through more density layer, it doesn't go through refraction. So it's very selective. So it's very selective.
Flatzoid, I agreed with you. I think you thought I said no. I said sure.
Okay, cool. So just based because of the distance from the sun and the atmospheric lensing, we have what we call parallax and perspective, and therefore it keeps it at that linear sinkages into the so-called horizon. So do you want me to demonstrate how I can show something going down just by moving it in the distance over a flat surface?
Well, I want to see bottom-up obstruction.
And bottom-up obstruction. Very simple. I showed you bottom-up obstruction a few minutes ago with refraction alone. Now I can show you bottom-up obstruction on flat surfaces by doing actual demonstrations without showing refraction. Well, there's always refraction, obviously, because we always look through an atmo, as you say. But let me quickly move to I'm just going to get the video up so long. But yeah, if you can understand that the sun is far enough away that the angular size change will be very minimal. It's the same as looking at something in the distance like a mountain. The further away it is, the less chance you have of it seeing to change angular size change. Let's see. Oh, sorry, my mouse is getting a bit slow on me. Just looking for a specific video.
But the angular size change that we see corresponds to 93 million miles, not to like a couple thousand miles in a flat Earth dome.
That 93 million miles you're claiming.
But you can crunch the numbers.
that 93 million miles away you're claiming, is that with refraction?
Is that with refraction? It just is the distance. I don't know what you mean with refraction.
Is it with refraction that the angular size changed with 93 million miles?
The 93 million miles includes mostly non-atmospheric space between us. So it's a weird question. I don't understand your question. It's 93 million
You're
miles.
claiming it's 93 million miles away. So
Yeah,
does that calculation of 93 million miles away take refraction into account?
Refraction doesn't change the distance.
Refraction changes the angular size.
But it doesn't change the distance. It's still 93 million miles.
If we're talking about angular size now.
Yeah.
So how do you know the distance if the angular size, if refraction is not taken into account?
I'm not sure even refraction changes the angular size that much. I don't know. I'd have to see that demonstrated.
You say refraction warps an image. That's why you guys claim things can come over.
Yeah.
Sorry, I'm just looking for the right of videos. Sorry. I'm looking at the wrong place. I've got so much videos and photos. I keep on having to go look for it. But yeah, there's definitely.
You want to talk about the flight times then?
No, I'm just quickly getting it. But so long, I would like you to tell me how you can validate 93 million miles of your sun.
I mean, yeah, you can do. I think they did a Doppler test even of it.
A Doppler test?
Yeah.
Can you go into more detail?
It was in the 60s. The military did a Doppler test, bounced a radar off the sun 93 million miles away. You can time it.
Do you know what a black body a black body is? What's black body?
It radiates with a black body spectrum.
And you probably say they used what did they use to get this radio wave?
It's just a radio wave emitter. I don't know.
So it's like a ham radio wave, in other words. Okay.
I don't know what they did. I mean, it was like the military technology in the 60s. I'm not the expert on the mechanism that they did. I know that they bounced the radio back. Same thing that they do with the moon to figure out the distance between the moon.
Again, if it's a black body, how's it going to let radiation? How's it going to be able to bring a radio wave back? Obviously, you don't understand.
Just bouncing off of it.
It can't bounce if it's black body.
No, that's actually not true.
Yeah, it's true. Okay.
No, it's actually not. You can bounce off the same way you bounce off the ionosphere. You bounce off of a plasma because of electric charges.
What ionosphere?
The ionosphere in the Earth's atmosphere. It's a layer of the Earth's atmosphere that.
You see, the thing is, all you're doing is you keep on begging the question based on your belief, and you're saying because of my belief, therefore globe.
I'm not
Everything doing... you haven't given actual any evidence for anything you've been claiming. You're just making a statement of claim and saying therefore it is. Okay, but now I'm going to show on screen again an actual demonstration of one of obstruction. Sorry that it's on the side though, but it's
what am I supposed to be looking at right now?
This is a flat bar piece of aluminium. It's flat. It's on my mixing bench. It's 100% flat. It's manufactured to be flat. Now I've got little what can I say, bottle caps placed on there, and then a little bolt at the back. As we're going to show you, we're going to zoom in, and notice I got a reference to a bolt showing I'm above all the time, okay? There is a bottle cap, another bottle cap, and then that bolt there. Does this bottle cap look lower than that bottle cap?
I cannot even make out the individual bottle caps in this image. I'm not going to lie.
Are you looking on your phone or your...
I'm looking on my laptop screen right now. It just looks like a bunch of black objects, but I can't differentiate them. I'm not seeing anything.
I'm just going to paste it in here so we can zoom it in for you to show you. Okay. Can you see it better now?
I see some darker black objects. Is that the bottle caps?
That's the bottle caps. This is the top of the one cap. This is the top of the other cap. And then this is the top of the bolt.
Okay. This is very like jumbled.
Does that bottle cap look lower than that bottle cap?
Then which bottle cap?
This bottle cap, the top one.
Oh, okay.
Does it look higher?
I see the top one now. It's much closer to the screen than the one that's farther away, right?
Great.
Okay. Now,
so it looks like it's going down, correct?
Can I make a suggestion? You should have used different colors of bottle caps other than black on a black background.
Doesn't make a difference.
It makes it a lot easier to see, but okay.
Okay, but anyway, you can see it's showing it go down based only on optics perspective because the angular size changes.
Yeah, it's getting farther away. It's getting smaller.
Great. So this bolt here is what I want to show in contention here with the video. Notice when I lift it away, you can see the bottom of that bolt. When I'm going a bit lower, it starts to vanish. And this side of top here is another bolt to show reference that I'm above the bar. That bar, I think I showed in the beginning where I actually, it's not on this one, where I actually painted the bottom red. You don't see the red part of that bolt anymore. This is showing bottom obstruction on a flat surface. This is just the one. I'm going to see if I can quickly get that one where I want to show you the sun setting, in other words, because that's specifically what you asked for.
All right, we've got about 5 minutes left there, fellas, before we go to Q&A.
I really want to make the flight times too, because that was kind of the main argument I presented.
All right,
I'd love to get to the flight times.
We'll stick another 2 minutes on the
now.
clock.
Awesome, thanks. Yeah, I just want to quickly get to this, just the video to show things do go down thanks to perspective. It's almost there by the video. Sorry, I just got so much things on my channel. But yeah, you see, it is just optical. We can show this optical all day long.
I don't think that you've demonstrated that, but okay.
So it didn't look like it was going down.
No, I mean, I literally didn't see anything.
Have you realized that the whole evening so far, your only rebuttals, I don't see it. So therefore,
yeah, because you haven't shown me anything I can see with my eyes, dude.
What?
All your videos are like really blurry and like it's just a bunch of like jumbled objects that you can't make out clearly or distinctly.
That's a lie, but okay. Anyway, check out. Okay, now this one is on in one of my primer booth. I'm going to show it's a flat surface. This light source is going to stay at exactly the same elevation, moving away in the distance, and it's going to appear like it's sinking into the distance. Notice that
that's just perspective, dude.
Yeah. Does it look like it's going down?
Yeah, I've never argued against that. I was talking about bottom-up obstruction, my guy.
That is bottom-up obstruction. I just showed you.
Oh, you just put it behind a surface. You moved it.
No. It's still exactly the same. It's still exactly the same height.
Yeah, you moved it behind an object, man.
I didn't move it behind anything. It's still the same height.
You didn't show bottom.
Look when I bring up the camera. See, it's same height. Go back down.
Didn't show any bottom up obstruction.
Wait. There we go. Sorry, I didn't show. I can show you a screenshot where it does show bottom up obstruction. This is called occultation due to foreshortening. This is another optical effect. See there it shows?
Oh, okay. Okay. Obstruction from like forward shortening. That is just like because of the angular resolution, right?
No. This is based on just the angle alone. The diffraction limit you're talking about is what I showed in the previous one with the bottle caps and that bolt. That's due to the diffraction limit.
Oh, well, we know that is not the case.
This is now...
We know that is definitively not the case with the sun, because when you look at it with a solar filter, you see that there isn't any blending with the horizon. It is clear. It is crisp. There's no optical blending going on there. It's not just...
Did I say diffraction here, or did I say foreshortening due to the angle?
So then... I don't understand. You're literally just physically obstructing it with an object here. That's not what you're claiming is happening on a flat Earth.
Exactly what happens on a flat Earth. When something moves away, it's moving further away. You got waves in the ocean, don't you?
Sure, you got waves on the ocean, Flatzoid.
Which would be due to the angle, which would be closer to you and have a larger angle to the bottom of the sun. So therefore, it would occult the bottom of the sun as it moves away due to perspective. Because remember, due to perspective, your horizon rises relative to eye level, while everything above sinks relative to eye level. So, everything moves to the vanishing point.
So you honestly think that there's a sun thousands of miles up in the sky that is...
I don't know the distance.
That is being... I didn't give a specific distance. I just said thousands of miles. That is high up in the sky. That is physically the light between that high up sun and the eyes of the observer is being obstructed by waves way down on the surface. That's what you think.
We can demonstrate this just like I did. When something moves further away in the distance on a flat surface, because of perspective, it ramps. Remember, the horizon ramps up.
That wasn't a flat surface.
Ramps down.
You had a thing.
It's a concrete. It's a concrete floor. It's my primer booth. It's flat surface. Now those paint tin cans were just to keep in reference to show you it keeping the same elevation, and I'm not changing its elevation, and it's to show it occults due to the angle. This is foreshortening.
It occults because you put something in front of it. That's not what's happening with the sun.
Was that light source above the tin cans at all time?
Here, in your example, right, you could draw a straight line from the light source to the eye, and you could see that there is a physical object in the way.
So like a wave on the ocean floor.
But
well done.
The flat Earth, there is no physical object in between the sun's light and the observer. The
ocean's not physical. So the ocean's not physical.
When did I say that, dude?
You literally just told me on a flat Earth, you don't have anything physical to show occultation for the moving away sun.
But you think that you can draw a straight line from the sun to an observer, and that straight line is going to get blocked by a wave that's like 2 or 3 feet tall?
I just did show you a demonstration.
That's very silly, man.
This was not taking refraction into account, just like where Rob Skiba showed his taking a Fresnel lens, sticking the sun and moving it away. It also brought it down to the horizon while keeping the same angular size.
What you have shown is that if a physical object gets in the way between the sun and the observer, then it will be blocked from the bottom up, which is what happens on a globe model with the Earth. But
there's a difference.
Maybe it's a failure of imagination on my part. Maybe I need a picture, but I cannot
just one
comprehend how anything obstructs the view of the sun on the flat Earth, much less a wave that's only a couple feet high. But I'd really like to go to the flight paths next.
Oh, yes, definitely. First of all, look at my hand.
Yeah.
You can see it's small, like the size of my head, okay? Look what happens when I move it too close. Is it bigger than my head now?
Bruh, I'm not arguing with that.
So, perspective then, foreshortening.
I'm never arguing with that. Perspective.
Great, so not a physical curve then?
No, that's not the conclusion at all. That is logical.
Angular size change. Well done. Okay, we can move to flight paths because you're not arguing against it.
Of you. Flatzoid, don't do that, man. Do not do that.
You know what?
Really, just 1 second, Flatzoid. I will be honest. I have given you quite a little bit of extra time, so we'll just let him respond there, and then we'll move on to the last point, and we'll try to get to the Q&A.
For you to say that because I agree with perspective and how perspective works, that somehow means that I've reached your conclusion, man, don't do that. That's dishonest. That's bad faith. That's poisoning the well. Don't do that, okay, man? Let's just move on to the next topic because I distinctly have not agreed with your conclusions, and I don't think that they logically follow from from perspective laws, okay? Let's move on.
You just said that you're not arguing with me about it, so yeah, you agree. Well done. That's what I said. So let's move on.
Don't be putting words in my mouth. I don't disagree with you about how perspective works. I do disagree with you about you thinking perspective causes bottom-up obstruction of the sun when the sun sets. I do not agree with that. I think you're wrong on that. I don't think that logically follows from perspective. So instead of you telling me what I think and that I agree with you, even though I explicitly do not, why don't we move on to flight paths?
Can I just ask you then to prove your point that it is physical and not optical? Because you would have to
have it's optical. It's a visible horizon.
So you agree with me then? Well done.
No, look, I agree with you that the horizon is a visible horizon. I agree with you that perspective makes this look bigger than this. Okay, we agree on those two things. Don't try to then say I agree with you on things that are not those two things.
I think you're missing the point altogether. You agreeing what I'm giving my argument, and then you're saying it's not what you're agreeing with. You're saying it's physical earth curve. So then I'm asking, okay, how are you going to demonstrate that it is physical earth curve and not the optical effect you agreed with me on? That's all I'm asking. How are you going to do that?
Because we can account for optical effects. We know how optics work.
Yeah, and you claiming it to be opposite to what the optics is showing with demonstration.
All right, I think
No.
I think we're going in circles here on this one,
Okay,
guys.
let's
So
move
Yeah.
to the next one. Yeah,
let's
I've
try
been
to get to the
trying
last.
to move on to the
Yeah.
flight routes.
Let's try to move on to the last point, and then we'll get into
Flight
that
routes,
Q&A,
okay.
everybody. So 5 minutes on the clock, and I'll go back to my silent modding here.
Cool. Okay, flight routes. First of all, when you know how the equidistant Gleason's map worked, the one you presented with the flight routes.
Okay, I said I don't care what map you want to use. Use any map you want.
Well, let's just say that's the one you used. Okay, that's the one you presented. Do you know it's only a longitudinal and time map? It's not made specific for distances.
Use
So it's a
any
straw
kind
man.
of
No,
map
no.
you want.
So it's a straw man to use it and claim distances and based
Use
on the
what
map.
flat Earth map do you want me to use?
All maps are flat, dude.
Which one do you want me to use?
It doesn't really matter because at the
Yeah,
end
because
of
the conclusion's the same. No matter what map
No.
you use, the conclusion's the same.
no, you presented a straw man based on a map that is not made for what you're presenting.
So show me the
It's
map that
showing-
works. Show me the map that works. How about that?
A map does nothing other than show a point of position.
Show me
That's
the
it.
map that's based on distance.
What map is? There's no map based on distance. A
I can
map
show
is-
you one. It's called the globe, and it works.
A globe's not a map.
Again, I can show you it. It's a three-dimensional map, and it works. All the
Globes are not
distances
maps.
are as they're measured.
Globes are not maps.
I don't
Maps
care
are
if you want to play a game of
two-dimensional.
semantics, whatever you want to call it, man. I can show you the globe, and all the distances work.
I
with
can
the
show you a
flight.
cube. Does that make it reality?
If all the flight times distances work on that cube, I'll listen to you. So
Okay.
can you show
You
that
want-
they all work on a cube?
Okay, first of all, I can debunk you saying it's a globe because of flight times, because you're ignoring your Coriolis claim of Earth spinning underneath it. How's
No,
that?
you're ignoring conservation of momentum. That's not how that works.
Conservation of momentum would be cancelled out if you go the opposite direction, mate.
No, your
Yes.
momentum is conserved in
Is
either
your
case.
air velcroed to Earth?
No, it's
Then
bound by forces.
then you can't claim conservation of momentum. Coriolis
Oh,
is
wait,
specifically
hold on. man.
Coriolis is specifically
such a false
I'm still
premise.
talking. I'm still talking.
I don't-
Coriolis is specifically a two reference framed effect. You got an inertial reference frame and a non-inertial reference frame. The Earth would be the non-inertial reference frame where you standing and observing the plane moving or deviating apparently over the inertial reference frame. So when you see a plane seen to deviate, it would be the plane only apparent because you are moving away from it. That's
We're trying to
Coriolis.
dodge this so hard, Flatzoid. First of all, your premise that if they're not Velcroed together, then the Coriolis and does not. Your conclusion does not follow from your premises. Okay, Velcro is irrelevant. They're bound together by forces that are measurable. Okay, get that through your head. But let's not dodge the topic here. Do not dodge the topic. I can show you on a globe all the distances that match with the flight routes that me, you, and everyone listening can verify for themselves. I have a spherical, if you don't want to call it map, I don't care, a spherical globe where all the distances match the flight routes. What do you have that shows that it's even possible on any flat map?
Sorry, your whole premise was the times it took to go across that distance.
Sure.
So now you're trying to move across to another argument, which is dishonest because you're talking about the times. So I'm literally debunking your time argument by saying Coriolis. Are you taking Coriolis into account or not?
Bruh, I'm literally showing the flight times that are given by 4 different companies that anyone can verify themselves. They match with what they should be when we look at them on a globe. Okay,
With Coriolis
I'm
or
not dodging
without?
anything. That was
With
my original
Coriolis?
argument. I've stuck on that argument. You need to address how that can be possible on a flat Earth. How are
With
the flat
Coriolis,
times possible?
with Coriolis or without Coriolis, those flight times?
Bro, I don't know. Do you have Coriolis on your flat Earth?
No, because it doesn't move.
So then without Coriolis, then explain those flight times to me.
Sorry,
on your flat
you're
Earth.
the one claiming a globe shows it to be perfect. So the onus is on you because you're making the burden on yourself. You, the one making the claim. So I'm asking you, the one who made the claim that it's perfectly times everything on a globe. Is this with Coriolis or without Coriolis?
I literally showed everyone. Again, this is my argument showing that those flight times are not possible on a flat Earth. I am asking you, Flatzoid, to show me how those flight times, which are everyone can observe to be the case, show me how that reality of those flight times can be possible on any flat Earth.
Easy. It's called flight dynamics. If you look at the flight dynamics, the plane needs a stationary, non-rotating Earth to function. Yeah.
Flight dynamics. You're just going to hand wave it all away and just say flight dynamics.
You just asked me, so I literally just told you.
Okay,
because of flight dynamics, the Earth has to not be rotating. It has to be stationary and has to be flying over a plane. That's how it works. You made the claim. Listen, you made a claim that your Earth, your globe Earth, shows it to be perfect. So your burden is on you because you made that claim. So you have to come and show me where on your globe it has those perfect times, either with Coriolis or not, because the Earth would be spinning under your globe model, which would show different time flights, because if you fly the opposite way, it would be totally different. It doesn't.
Because of the conservation of momentum, when the planes take off, they don't just suddenly lose all the momentum that they had when they were on top of the spinning Earth. That's not how physics works. So, yes, the flight times are accounting for the Coriolis effect. It is taken into account in the model. I showed it. I'm asking you for the 15th
so
time.
Charlotte,
no, I'm asking you very explicitly here. Your answer was flight dynamics. Somehow flight dynamics explained it. I want you to explain to me how flight dynamics can explain specifically the flight times for those routes that I showed you.
Easy. Flight dynamics, when anybody goes and actually studies to be a pilot and actually does it, they don't take Coriolis into account because Coriolis isn't taken to. They need to use it as a stationary Earth. If you take it into Coriolis, it won't work out. Just like when you take Charlotte, Carolina, moving to
you're dodging. LA. You're not answering my question.
Listen, based on your Coriolis globe claim, it would have to be 4 hours difference. It doesn't have that 4 hours difference. It goes in the opposite direction.
Math. You're not doing that math correctly.
Dude, again, you're the one trying to... No, I'm not dodging anything. I'm keeping you to your burden.
What was my question, Flatzoid? What was my question? I asked you to specifically explain the flight times. Specifically.
I am. And my rebuttal is simple. You use the straw man of a map that does not made for what you're claiming, and you made a claim that it as only working on a globe is your burden. Now I'm trying to ask you, because you made this claim that it can only work on a globe, you would have to provide evidence. Is it Coriolis or not? And I'm telling you, based on flight dynamics, there is no Coriolis taken into account, which shows your Earth is not rotating.
No.
Therefore your times are not working, because if you do take Coriolis into account, nothing of your time will work on your globe.
Here's where you're messing up, right? The way that you're taking Coriolis into account is literally incorrect. You are not doing that physics and math correctly, because you are forgetting about the conservation of momentum, a very basic concept in physics, dude. You are not doing that math correctly. You don't need to account for this effect because you have conservation of momentum in that airplane. You're not just going to lose your momentum suddenly because you go up in the air. Okay, so
oh really?
A billionth time,
you don't lose conservation when leaving a reference frame.
Yeah, your momentum is conserved. It's a physical law. So here you go.
Do you lose conservation?
Let him ask his question there, Flatzoid, and then we're going to move on.
Continue to not answer my question. So tell me, how is it possible? I showed you those 4 paths, those 4 flight times. Specifically address those flight times and tell me how that is possible on, hear my words carefully here, any flat Earth map, any of them.
They are only possible on a flat Earth because when you have flight dynamics, it has to be stationary. Hence why your globe not taking Coriolis.
You're dodging again, dude. You're dodging again.
Let's let him answer it the way he's going to answer it there. I know it, might not be what you're looking for, Grayson, but this is the way he's answering the question, and then we'll have to move on.
Yeah. On a flat Earth, there's no movement. just like flat dynamics depends on no movement of the Earth. That's why it works over a flat Earth, because your globe specifically is claimed to have Coriolis. Conservation of momentum is not indefinitely conserved. As soon as you leave your reference frame, it loses that momentum. That's why I asked you, is the A Velcro to the Earth? And it's a no. So based on your globe claim, just it has to show Coriolis or it doesn't. Because if you're claiming Coriolis, then you cannot claim to have a Velcroed conservation of momentum. If you don't claim Coriolis, great. So they're not a globe. No matter which way you look at it, you're straw manning a flat Earth because of your burden that you claimed on a sphere Earth.
So basically, any map is a straw man of flat Earth, because flat Earth, you can't demonstrate a map because you know.
I didn't bring up a map.
Don't interrupt. I did not interrupt you this last time. Any map, you know that these flight times are nonsensical. Any map that any flat Earth map, these flight times are going to be nonsense. They're not going to make any sense anytime you try to map these out. Anybody can do this themselves. Just plug in different cities and you can prove to yourself that the Earth is a globe. What he's talking about with Coriolis is complete nonsense. He doesn't know how the physics works in this case. We could go through the calculations. He doesn't know what he's talking about. Every physics teacher in the United States would disagree with Flatzoid on this. Go ahead. I encourage everyone in the audience, contact your local physics professor and ask them, and they can all tell you what Flatzoid just said is utter nonsense.
I'm sorry, Ryan, can I ask for 5 more minutes where we can just talk about Coriolis? Because I think he doesn't understand how Coriolis works.
Sure.
Is that fine?
Like I said, we can keep going on we just want to make sure we're respecting everybody's time. And yeah, I was going to say,
can only do 5 minutes still, yeah.
Yeah, we'll do another 5. That's cool. Let's do that.
Cool, thanks. So base theory, Grayson, can you please explain to everybody what Coriolis effect is, please?
Yeah, it's from the rotation of the Earth.
No, what is Coriolis effect?
Yeah, it's from your rotating like inertial frame, basically. Like you basically like, you know, in the southern hemisphere, the northern hemisphere, the things are going to rotate differently because of the Coriolis effect. You're going to have, it's basically like a pseudo force that's applied to objects in motion when they're in a circular, like a rotating reference frame.
No, can I correct you quickly? The Coriolis effect is based on 2 reference frames. You being on the moving reference frame, which would be the non-inertial reference frame, seeming to have an apparent deviation of an object in the inertial reference frame. No, the airplane.
Inertial reference frame can be
I
moving.
let you talk.
Right, let's give him another 10 seconds here. And we'll
the plane is in the inertial reference frame, having the apparent deviation as you move underneath the plane. So not actually deviating, it just appears that way. There's no actual conservation of momentum in the second reference frame because it is flying in a linear fashion because you're moving underneath it. It appears to have that deviation. That is Coriolis, mate.
So you can just do all the same reference frame. You can have the Earth as your inertial reference frame for the literally.
Then it's not Coriolis. Then it's not Coriolis. This is why. Sorry, that's why I said I see you don't understand Coriolis, and this is why you don't understand the argument. This is why I had to get you to understand.
So just FYI, the Earth itself is an inertial reference frame, and you can calculate the entire flight based on the reference frame of the Earth. So you can use
a non-inertial.
Just one second there, Flatzoid. We gotta let him respond to some.
You can actually pick any inertial reference frame that you want. You can do a train moving at a constant speed. You can calculate the entire plane's flight relative to that train. You can do that if you want. That's totally valid within physics. It's the principle of relativity.
Again, the Earth is a non-inertial reference frame.
That's not true.
Yes, the inertial reference frame is the plane moving above you.
If it's moving at a constant speed, that's true. But if it's not moving at a constant speed, that's not true. But the Earth is also an inertial reference frame. This is a basic fact of physics. Shake your head all you want, but you're just denying.
I'm correct. I'm trying to help you out. I'm trying to help you out what Coriolis is. I don't know how much specifically I can make it. The Earth would be the non-inertial reference frame.
False.
The plane would be the inertial reference frame.
Again, you can pick any arbitrary inertial reference frame that you want, and it's not going to change your calculations in this.
It changes all the calculations based on your globe having Coriolis or not changes your flight times dramatically. And both of them change the flight times based on your claim. Both of them.
All it
So
does,
showing it doesn't work on your
all-
globe.
all it does is change the coordinate system. It doesn't change the actual fundamental physical
It
relationship.
changes the actual times they would take to travel from point A to point B.
That's a loadable.
It's calculable.
Then do it.
Okay, I'll make a video on it for you. How's that? When I've got the time.
All right, sounds good. I'll watch it and debunk it.
Good luck. I guess that's the 5 minutes.
Yeah, we can carry into our Q&A there. So just remind everybody in the live chat to hit the like and share this out in those spaces you like having these discussions. Shane, I see you're hanging out in the live chat. If you want to pin the poll there, I think it disappeared on me, so maybe other people aren't seeing the poll that we put up. So yeah, if you want to put that back up with the, also add the option of, no, I'm an ultimate soylent drinking soy boy. That'll make everybody happy. So we're going to get into the Q&A, everybody. Once again, I'm going to drop the needle like a broken record and remind y'all, Dallas, Texas is where we're going to be. Let us know in the live chat where you're hanging out and if you're going to be able to make it to our show, our live person event this weekend. Tickets are in the description. And if you can't support us by actually making it there and meeting all the awesome people that come out and debate at Modern Day Debate, then you can also check out our crowdfund where you can get access to perks. So that includes, I see Leo Filius is hanging out in the live chat. So if you want Leo Filius's signature, you can get that by checking out our crowdfund. You can get a picture of his face with a sign. Anyways, you can also get a signed emblem, whatever you'd like. So yeah, definitely check those links out. Let's get into that Q&A, everybody. Once again, speakers are linked in the description here on screen. And thank you guys for being here. Mark Reed, membership chat, says, I'm glad to see Grayson and not Peyton Manning. All right, let's carry on. Question for Flatzoid. Why is carrying a weight up a slope or stairs harder than a long, level surface?
Because you're burning more calories, so you're using more energy. Quite simple.
Okay. Any thoughts over there, Grayson, or we can just move on?
Yes, because of the force of gravity.
Okay. LJ coming in. LJ, you're in the right spot. He's always coming in with his super chats about the flat earth on every chat. We appreciate you, bud. And I'm glad that you made it in for the right occasion. So he says, base theory started his opener with NASA pics, yet if you YouTube real footage of space, in quotation marks, all vids are CGI. Give observable scientific evidence for the globe. It's quite a bit there, LJ, but he's saying that all space footage is CGI and to give observable scientific evidence. So we'll just wrap that up.
Yeah, so once again, all they have is it's all just a conspiracy. All the pictures, it's all CGI. It's a conspiracy. That's exactly what I said that he would show. And the evidence that the Earth is a globe, there's a sunset. You can measure spherical excess yourself, or you can see the measurements of spherical excess. You can see different plumb bobs not being parallel. That's another measurement. The flight times is evidence. I provided a lot of evidence in this. I could go on. I used antipodal focusing in the last debate to show that it cannot be flat.
All right. Well, we got a lot of super chats, so there'll be lots of chances to respond to each other's statements there, I'm sure, as we weed through. And keep your super chats coming in, everybody. We appreciate them. Hit that like button. Kango44 says, question for Flatzoid. Please explain the sunset. The angular size of the sun does not change as it sets, so it's nothing to do with perspective.
Has everything to do with perspective. As I said, it can be demonstrated looking through lenses like a Fresnel lens, because the atmo magnifies what we see as it moves away in the distance. And because of parallax and the sun is so far away, the angular size change is minimal.
Yeah, so then that just violates how perspective works then. Because if the angular size change is only minimal because it's so far away, then it's not going to be obstructed bottom up from the horizon. So
yeah, that's totally a red herring, because the thing is the bottom. Remember when I explained something moves away in the distance, as it moves away in the distance, it gets blocked due to the angle. Perspective just is an optical effect where it rises up. It doesn't physically rise up, mate.
Yeah, show me the math on that. I don't think that the actual formulas for perspective can support that.
All right, this next one's coming on, and as soon as my middle finger scrolls up to it, the old magic scroll here. LJ coming in again, buddy. Once again in the right spot. Number 9 taped to the ceiling will show 6 on the opposite side. If a 6
That's for you, Grayson.
turns
That's for you,
out to be
Grayson.
9. I was gonna say you triggered my Jimi Hendrix there. What a great tune, but I can't sing too much of it because they will demon the absolute. Anyways, go ahead there, Grayson.
Yeah, well, I think that if you were to actually plot the position of the moon in the northern hemisphere and the southern hemisphere skies as it progresses around, you would see that it doesn't match this whole idea that, oh, you're just looking at it from these two different perspectives. It doesn't track in the same location as we would actually observe it in the sky above. If you just make your little model of your little flat Earth, I know that none of you can pick an actual map that works because none of them work, as we saw in this debate. But if you make your little model and you say, oh, well, here's where the moon would have to be in order for these northern and southern hemisphere people to see it differently. And then you say, oh, well, if the moon was in that location, this is the location that we should see it in the sky. Then you go look at it in the sky and you see, hey, it's not there. It's not in the right location. Flat Earth debunked again.
All right, let's carry on there, fellas, before I get any more triggerings in the chat there. But yeah, good job, LJ, triggering the Hendrix over here. DJ Mossy, and thanks for your answer as well, Grayson. Let's carry on. Hi, Flatzoid. Can you tell the circumference of the Tropic of Capricorn and the Tropic of Cancer? Floor is yours, Flatzoid.
No, I don't know it off by heart. This is the thing they asked me last time as well. I don't really need to worry about it because it doesn't bother me. I don't travel the Tropic of Capricorn or Cancer, so it doesn't bother me.
So again, the point is that in a globe model, they're the same distance, but in a flat Earth model, they cannot be the same distance. And in reality, if you were actually to travel them, they'd be the same distance. Thus, another debunk of the flat Earth.
What flat Earth model? You keep bringing up flat Earth models that you're making claims with, but you haven't presented any.
Any of them. Literally any possible flat Earth model.
This can go into a whole different debate, but just the way they measured the radius proves it's flat, mate.
Yeah, okay. Nice claim without evidence.
We've actually done streams on this. You might want to go watch my channel.
Oh, you've done streams? You must have proven it.
All right, let's carry on there, fellas. It's been a lively one here, and these fellas, they definitely know how to do the tug of war when it comes to the conversation. This isn't these guys. This isn't their first rodeo, if you will. Hey, you know what the cowboy said at his second rodeo? This isn't my first rodeo. Anyways, let's carry on. That's so dumb. That's dad joke 100. All right, DJ Moss. We just read that one. Kango44. Question for Flatzoid. How did the Himawari 8 capture the Tonga eruption in real time? Do you think teams of people are busy photoshopping satellite footage as events happen? Have a little think about it.
It doesn't take in real time. It takes, I think, 10 minutes for it to actually get to Dataville. So yeah, and you do know we still think there's balloons up in the sky, and there's ways to take photos, high photos. So it doesn't mean anything. There's no one said anything about photoshops there.
So you are actually agreeing that the Himawari satellite, even if you think it's a balloon or something, you are agreeing that it is taking actual photos of the Earth in even if you don't like real time, every 10 minutes.
No, I didn't say that. I said anything. It's not in real time because he claims it's in real time. I'm saying even based on flat Earth, we still think there's balloons up there. So total straw man.
So if this Himawari
no globe, in other words, it's nothing to do with a globe or flat Earth. It's just simply fixing his statement that it's taking it in real time. That was his claim.
Okay.
All right, let's carry on there. Just say hello. Yeah, I hear you there, human girl. I did make a bad dad joke. You can tell me, you can answer your punchline there. And hi, Monty, as well. Thanks, everybody, for coming out and enjoying the discussion we're having tonight. So base theory keeps interrupting. Flatzoid, wonder why. That's from LJ. Well, I saw this one earlier, and that's why I kind of said I feel like these guys had a really good tug of war. You know, they kind of pushed and pulled as they needed to, and you know that makes things pretty all right for me. So I think we've had a lot of fun. Let's carry on. LJ says, base theory, it's the South Pole. Source, trust me, bro. Looks like he's parroting you there. Any thoughts there?
Oh yeah, sure. About 250 people use the White Desert Company every year, and they go to the South Pole. You can go there. I encourage you to do it yourself if you can afford it. It's pretty expensive, but if you go there, you can tell for sure that it's the South Pole because you can take a compass with you, and you can see every direction around you is north. No more east, no more west, no more south, only north. Therefore, it is the South Pole, which again doesn't make any sense on a flat Earth model. Makes complete sense on a globe model. Flat Earth debunked again.
Can I just make a statement? Because I wanted to actually talk about this in the debate. It's the ceremonial South Pole, not the actual South Pole. And yes, magnetic fields do exist.
Yeah, but they would only converge if they're coming out of the North Pole. The only way they converge is either on the bottom of your little torus plane or on a spheroidal Earth on the South Pole. That's how magnetic fields work. They don't just all converge on a random spot way out there on the ice wall. That doesn't make any sense. The way that you know it's a South Pole is that 250 people go there just from this expedition. Hundreds more go there in other ways, and you can measure the magnetic pole yourself. You can take a compass with you. I encourage flat earthers, go donate to somebody. Try to send a flat Earth representative to the South Pole. It would be awesome. I would watch that documentary. Personally, I think they should make a documentary where they just send flat earthers to space and to the South Pole. I think it'd be hilarious.
Yeah. Again, it was just a ceremonial. And you do know the magnetic south is not at the ceremonial pole.
It is the magnetic South Pole, so.
All right, let's carry on from there. I think my camera was having a little glitch for a second there. Never mind me. Let's see. Steven send in $4.99. There's no question attached to it. So if you have a question there, Steven, throw it in the live chat, and I'll try to keep an eye out for it. LJ says, coming in again for $4.99. Flat Earth pilots are OFC scared to talk about it to not lose their job. Why doesn't the sun light half of the ball all the time? It would on a globe. That's for
because
you there.
That's not what it would do on the globe. So,
okay. Kango 44, a question for Flatzoid. Can you please explain why tow tanks that test boat hulls account for curvature along the 200-meter length of the tank?
We've been through this before. It doesn't take earth curve into account. The tow tanks just take water depth into account.
I'm not familiar with the specific example, but it sounds interesting, and I'll look into it.
Yeah, it's been an argument for about 2 years now.
All right. Let's carry on there. Kango 44, question for Flatzoid. Can you please explain why the London Underground Crossrail tunnels had to take the curvature of the Earth into account when being constructed?
It didn't take earth curve into account. It just took into tunnels to line up to the next account. They start at one point, start another point, and they have to line up. Doesn't mean they took earth curve into account, mate. It just means they took their relative position to each other.
I would really like to know how you know that they didn't take earth curve into account.
Sorry, because this has been a discussion for years. Remember, I've been a flat earther for many years now. We've discussed everything they're bringing up. That's why.
Yeah, but how do you know? You didn't answer how you know that they didn't take it into account.
Okay, how do you know they did?
I'm not familiar with this example. I'm just asking you because you said explicitly, you made the claim that they did not take it into account. I'm just asking how you know that.
Because there is no earth curve to take into account.
Oh, so now you're presupposing your conclusion. Isn't that funny?
Weird how you're trying to muddy the waters. The guy asked me a specific question. I answered it. If you don't know anything about the subject, roll the...
I just asked you how you know that they don't take earth curvature into account.
I told you.
Your answer to that was that you know that they didn't take into account because you already know that the earth's not curved. So
right.
you are
Whose
presupposing your
question was this to? Whose question was this to?
We
Oh,
are
now
going to
you
give you
don't want to
the.
answer. Now you don't
Sorry,
want to
I
answer.
already
Now you
answered.
appeal to the
I did
moderator.
answer.
We
I
are
did
going to give you
answer.
the last word on that, and we can move on at any point. That's fine. So let's ask the next question. Into the break, Grayson, there is a law of non-contradiction. A word cannot mean both a synonym and an antonym.
Oh, no, actually, just last week on Jeopardy, they had an entire category of words, the same word, where the definitions had two definitions that were contradictory to each other. You can go and look at the category yourself. There are multiple words where, depending on the context that you use the word, they can literally mean the exact opposite meaning. There's a number of examples of this. It's not the law of non-contradiction because, again, there are two different meanings of the same word based on the context. This is how language works. You're just arguing with the dictionary at this point.
All right. Let's try to carry on from there, guys. LJ says the Globe debunked live once more. So you think you got a fan there through LJ, Ryan, and Modern Day Debate #1. Well, thank you, LJ. I think we are one of the few places that definitely try to engage as much as we can with a very diverse grouping of politics and science and religious debates. So, if you haven't already hit that like button, definitely do so. We definitely like to give people the platform and keep it neutral over here. And let people express what they really. What are you really thinking? How do you really feel? Tell me how you really feel. All right, LJ says, base theory keeps interrupting. Oh, we already read that one. LJ, any proof of Jupiter's mass, its size, and gravity?
Yeah, from its gravitational effect, you can calculate its mass.
Okay, you want to move on from there? That was pretty quick. All right, we'll just keep moving on.
I mean, they've been able to do that for hundreds of years, so.
So circular reasoning. Well done.
It's not circular reasoning.
It is. You base it on an assumption of a sphere having mass and gravity. Therefore, calculate it. So therefore, it is. Well done.
Again, you're not presupposing what the mass of Jupiter is. Your conclusion is what the mass of Jupiter is. Your process is observations of its gravitational effect on other bodies. So at no point did you assume your conclusion. There's no circularity involved.
You just did. I assume gravity. I assume a mass of Jupiter. I do calculations based on that assumption. Therefore,
Last
circular
word,
reasoning, mate.
you there, Grayson?
Again, your conclusion is not that gravity exists. Your conclusion is what is the mass of Jupiter. So in order for it to be a circular argument, your conclusion would have to be like gravity, therefore gravity. But that's not the argument. The argument is observations of gravitational effects. Therefore, you can calculate Jupiter. That is not circular at all, like the mass of Jupiter. You're not presupposing your conclusion.
It's circular and affirming the consequence.
It absolutely is not in any sense of those words.
All right, let's move on from there. Lots of good back and forth there. See, I didn't let you down. I fished a little bit to get a little extra on that super chat. Mark Reed, why can't you address the points that Grayson brought up Flatzoid? Sunset, sunrise, flight times, moon being flipped upside down. Why are you dodging? That's from Mark Reed.
Why are you lying, Mark? Everybody saw it live. We had actual discourse on these subjects.
To give him the benefit of the doubt, he probably sent that in before we finished the whole debate. I mean, that happens all the time.
That's fine. Sometimes we have questions and I'm like, yeah, that was completely already discussed. That's fine. But thanks, Mark Reed. Anyways, we appreciate you, buddy, and all you do here at Modern Day Debate. LJ, $1.99, probably for you as well there, Grayson. Would y'all ever get on a 17,500 mile per hour roller coaster?
Well, I don't ride any roller coasters. I'm not a big fan of roller coasters in general. But if what he's trying to do is try to say, oh, but the Earth is traveling so fast. I mean, this is just, again, complete ignorance of physics. Like, you're not going to feel something that's going at a constant rate. Like, you don't feel that. You feel acceleration. You don't feel absolute speed. That's just basic physics 101. Take a high school course.
And can I give a statement to that quickly? Then you can do closing. Yeah, you do know your Earth is moving in different vectors, so therefore acceleration constantly. Well done.
Yeah. Well, again, you don't feel that. It's not something that you feel. You're moving at a constant rate. There you go.
All right. Next one coming in from Hate Stairs. Flatzoid, speak a little more about why you have a beef with Walter Bislin's calculator. Are you claiming refractive indices are constant and don't change with external conditions such as temperature?
Walter Bislin's terrestrial refraction is not light refraction. It changes the radius of the Earth. So it makes the actual radius to be flatter or smaller compared to how he wants it to sort his, how can I put it, observations out. And the flat Earth model he placed there is a total straw man as well.
Yeah, well, if you actually go and you look at the source code for that and you look at the formula that he's actually using, you'll see that the R value remains constant in the formula in the source code. So you're just lying about that. Sorry, Flatzoid.
I showed it on, again, videos on this, where I go to Walter Bislin and you show him even in his formula, the radius changes due to refraction. So you might need to go and look up the source you're trying to punt, mate.
All right, well, let's move on to the next one. And just before we do, I'll let everybody know, as I've gotten into, our poll just closed. So our viewers right now have voted on what shape is the Earth. So 68% voted it's a sphere, and 31% voted it's flat. And we had a total of 356 votes. So more people did vote that it's a sphere than it is flat. But my real question here is 356 votes. You got the thumb power to vote in our poll, but only 134 likes. What are you doing with your thumbs, people? Come on. I'm calling you out in the live chat for your weak thumbs, all right? Get those thumbs up on the likes, because that gets that helps us beat the algorithm, okay? Thanks, guys. LJ says, even my dog can see Zoid's images are not the same. Any thoughts there, Grayson?
Yeah, your dog might have cataracts or something.
Well, that's quite the response. All right, let's carry on. Jeez. TJ Moss, Flatzoid, using your arrow moon, why do those human objects cannot see the same amount of empty space between the arrowhead and the circle border?
It was, don't understand the question, but yeah, it was just simply showing that it changes its rotation based on your location. It's got nothing to do with a globe or flat.
All right, we can carry on from there, I'm pretty sure. D's King Hacky says, hey, Ryan, did James discipline you for the Witsit debate the other day? I'm not going to read all of this, but no, me and James get along fantastic. And there's never any real problems as far as modern day debate goes. Things happen all the time on the air, and we just kind of roll with it and try to learn from it and do better as we go forward. So whatever you may get out of that, that's on you. Mark Reed, the light demonstration shows the light source gets smaller as you move it away. Why does this not happen with the sun and a solar filter?
Simple. It's called parallax. The sun is far away, just like a mountain would be far away compared to the trees right in front of you. If you move away, the trees will get in angular size quicker, smaller than it would be the mountain in the background. Far away, closer.
So you can actually crunch the numbers on this and see that they don't work out. There is a formula for calculating the angular diameter of an object. You can plug in the numbers yourself, do the measurements yourself, do multiple measurements from different places on Earth, and you'll see that the numbers don't work out. And once again, you can do this yourself very easily and debunk the flat Earth. Everyone at home watching can do this easily. Just measure the angle to the sun. You can measure it all, put in the numbers, angular diameter formula. Check it out.
Great. And notice the angles require flat Earth to be taken.
No, they only require a horizontal plane. That plane does not need to be the Earth.
Oh,
great.
I did miss a little compliment there after that. Did James, my brother in debates, discipline me? Absolutely not. He also did say, in amongst a couple ad homs, based theory, great intro. So I don't want to miss the compliments while I'm dodging some of that. So DJ Moz says for €2, Zoid, did your sun go behind mountain or horizon?
None. It was an apparent occultation due to the angle being limited as it moved away. It's called perspective, foreshortening. Just like my hand foreshortens my face right now, it's not physically blocking my face. It's the angle.
And that's not how perspective works.
Foreshortening.
All right, let's carry on there. Hate stairs, don't we all? Flatzoid would rather argue from incredulity and nitpick rather than presenting flat Earth. That's why the debate title changed from its original Flat Earth on Trial. I will tell you right now, Hate Stairs is the person who organized the debate. The pitch for the debate was globe versus flat Earth. So, as the expert here in the room on who organized the debate and what the topic was, I'll answer that one for you. LJ, $1.99. Only Flatzoid has presented observable plus repeatable. Thoughts there, Grayson? And then we'll pass it over to you.
Yeah, the sunset, totally observable. Flight times, easily observable. I mean, come on. How can you say that those things are not observable? I literally tried to make it as cheap and easy and accessible for everybody to observe this evidence as possible. So if you cannot observe a sunset, that means you either got your head in the sand or your head up your ass.
Yeah, but he's saying repeatable. So in other words, I'm the only one that's able to demonstrate it. You haven't demonstrated, you've just made claims.
The flight times demonstrates it.
You didn't even get Coriolis. Coriolis debunked that argument.
It doesn't, though. You're just incorrect about that.
All right. Let's carry on there, fellas. We got a couple more super chats coming in. Grayson says, for both, can you tell us where to find detailed diagrams of how the sunset works in your model? So some references there, fellas. Where can they find a model of how sunset works or on your model? So I'll ask you first there, Grayson, then we'll hand it over to you, Flatzoid, to close it.
Well, an elementary school textbook for children usually shows it. You can look at any simulation you want. I mean, it's readily available. You got the entire internet at your fingertips. So again, it's really not that hard to see. You can literally just look at a globe and look at a distant light source, and you can see as the globe turns, you're going to have a sunset. Pretty obvious for everyone.
Yeah, first I have to point out the model is not reality. Anybody can model a donut Earth having a sunset. It's not going to change reality. And yes, you can definitely show it just based on changing with distance and angles, and then placed in with optical effects. Simple as that. And you can go check Life is Short channel on YouTube as well. He actually does a good whole detailed thing on bottom-up obstruction as well. My channel also shows demonstrations of bottom-up obstruction. A lot of flat earthers channels do. We have actual demonstrations for this, unlike them placing it in children's books saying, see, I drew a sphere, so therefore it's a sphere. The difference is we have actual demonstration. They have faith, bro.
Okay, so I'd just like to ask any flat earthers that say that they have demonstration of this, please send them to me, because Flatzoid clearly did not show it in tonight's debate. He didn't show any bottom-up obstruction due to any perspective laws. So I would like to see some actual real demonstrations, if you have them, of how the sunset works. Flatzoid couldn't do it tonight. I didn't see anything from him that actually did show what he was claiming to show.
Is this the closing statements now?
Well, not quite. I was going to say we'll finish off the super chats. We got a few more to go, but we'll whip through them because I know we should wrap this up here shortly. So if you haven't already, hit that like button, everybody, and I'll do one final ticket pitch before the end because you're all dying for me to mention it one more time, right? And Dr. Dino says, Flatzoid, I grew up on a straight stretch of the Mississippi, could see it and boats on it slip beneath the horizon. It follows the curve. Sorry. So
again. All optical. Just like I demonstrated that Grayson says I didn't demonstrate, I showed bottom-up obstruction on flat surfaces. I've done many demonstrations of this. I got many globers try to debunk me that demonstrate bottom-up obstruction on flat surfaces. Just because you see it have bottom-up obstruction doesn't make it a globe. Again, we can demonstrate the optical effects on flat surfaces.
All right. And Dr. Dino strikes again, asking you, Flatzoid, any interest in debating Earth's age?
Yeah, but I don't know what we're really going to debate. I'll just say it's a young Earth, but I can't say the exact date, so I don't really see what we can debate for an hour or something on that.
No problem. All right, so Chase Hatchett says, convince me that flat earthers aren't just trolls or scammers. So Chase is accusing you of acting in bad faith. So any thoughts there, Flatzoid?
Well, you can go check my channel, then we'll see who's a troll, because it's a bit difficult to be a troll and have thousands of videos and live streams dedicated to a subject.
It's really
I would say the trolls are the ones which are obsessed with the channel, like my globe trolls, which I ban at the end of the day, and they create new accounts to come troll again. That's a troll.
So I just want to say, like, a lot of the prominent flat earthers are trolls because they're getting enough money to where they can take these flights themselves and demonstrate that the earth is not flat. Like I said, I don't know if Flatzoid's in South Africa. He could take any of the 4 flights that I showed, looking out the window, holding a compass in his hand, and he could show for himself and his whole audience that the earth is curved. He could do that if he wanted to.
Did you know a compass doesn't work in a plane perfectly?
Yeah, it's going to show north.
It deviates because of the magnetic fields inside the plane. So that's why you can't really use a compass properly on the plane.
All right.
You always have some reason why you can't just look out the window.
Hey, this is the globe argument. I asked Wolfie to do it. He said you can't do it on a plane.
All right.
He's a glober.
You know what you can do on a plane is look out the window. And that alone shows you that the earth is curved.
Flat. No.
All right.
According to your model, you can't see Earth curve in an airplane. Even Neil deGrasse Tyson says you can't see. Even Neil deGrasse Tyson says you can't see Earth curve.
No, wait. You're
height of the
misunderstanding me, Flatzoid. Hold on. You're misunderstanding me. When I say look out the window and see that it's curved, I'm saying you can look at the land that you're passing, and so you can see the actual route that the flight is taking, and from the route, you can know that the Earth cannot be flat because of the flight routes.
All right, last word there, Flatzoid, and we'll move on.
Okay, based on even Wolfie's showing that in the cockpit by flying, it only shows taking deviation and you don't see the deviation. How do you know which one you're
That's not what I'm saying. Flatzoid,
Sorry.
listen to what I'm saying. Right?
My closing statement.
I was going to say, we're going to try to move on. I'm sorry there, Grayson. But there might be a chance to respond if you hold your thought if we get another question. So Mark Reed comes in, says, after show on Mark Reed. Great job, Grayson. No explanation besides bad photos and terrible excuses. So I just messaged Mark and I asked him for the link to the after show. So you're probably both welcome to join there. I might take a rain check just because I have a flight tomorrow out to the old debate con. Let's carry on though. I think we've already touched on a lot of that there, Mark Reed.
Well,
but yes, after show over there.
If Flatzoid flies to the debate con tomorrow in Dallas, going from Johannesburg to Dallas, he can look out the window, see what route he takes, and see that the Earth is not flat.
Flying over ocean. Well done.
Okay. Next one, Esteban Ilbaca says, Flatzoid flight dynamics don't imply flat Earth. It's assumed in simplified models, but accounted for in advanced. Coriolis requires one frame of reference, the rotating one, but it affects objects moving in it. Thoughts on that?
Okay. First of all, you can ask any pilot. They don't account for Earth's rotation because of flight dynamics. And secondly, no, Coriolis requires 2 reference frames, not 1. So he's literally speaking out of ignorance.
Okay.
What the commenter said was accurate.
All right, let's continue on there. We only got a couple more to go. We'll try to whip through them. Sagoma says, how do you circumnavigate a flat Earth? 30 seconds there, Flatzoid.
Easy. Let's say you walk around your pool. You've just circumnavigated your pool.
All right. Let's carry on there. Wait, I believe, Flatzoid, is moon a sphere or a disk? Why can we only see one side?
I have no idea. It does point more to a spherical kind of look, but I wouldn't say if it's flat or a disc. A disc or a sphere. I don't know.
Is it made of cheese or plasma?
Ooh, maybe both. Plasma cheese. How's that?
Ooh, yummy. All right, let's carry on. LJ says, why wouldn't the sun light half the spinning ball? That's for you, Grayson.
Why wouldn't the sun light up half the spinning ball? Because when you light up a sphere, you don't see 50% of it. I mean, that's just not how that works in real life. So it's a false premise.
All right. Any thoughts over there before we move on?
Yeah, according to your model, it will light up 50% at a time.
Nope. You are mistaken if you think that's the model.
All right. Well, let's carry on. I just posted the after show link to Mark's StreamYard in the chat there. So if you guys want to join that, you're welcome to it. And I just put the YouTube link for all of you in the chat. So there you go, Mark Reed. I think I've done everything I can for your super chat. Maybe I'll pop in for a second. All right. So Retro Bill says the opposite of whatever Mark Reed said. Well, we'll get out of that what we what we can. Your hooligan says, Ryan, what are you doing this weekend? Oh, Justin, that's the other moderator that's been joining us on Modern Day Debate. Justin has actually got a really awesome, musical history, working with some really prestigious acts like Rolling Stones, and you name it, he's probably worked with them. Like, super cool guy. I couldn't believe the amount of awesome people he's interacted with. But what am I doing this weekend? Of course, you all know what I'm doing this weekend. I'll pitch it now. I'm going to be at DebateCon 4, and hopefully if you guys are in the area, I'll see you there. We've got all kinds of amazing perks. There are 2 ticket tiers, so you can actually get a VIP ticket and get access to extra perks. So check out the tickets in the description if you want to be there. If you can't be there, we're going to have all of the debates posted on YouTube. So, if you want to help support by putting in super chats or super chats tomorrow, that's great. Or if not, you want the signed emblem, you want a signed picture of your favorite speaker, and you want to just throw some in the crowd fund, we appreciate that too. Anything extra is going to go towards the next DebateCon. That'll be my last pitch for that. This is the last chance for you guys to get tickets. From my perspective, Justin will get in your ear tomorrow night. So LJ says, basic theory, tell everyone you believe in the moon landing.
Yeah, I mean, the moon landing is pretty obvious. Like, it happened because, again, the USSR observed it happened, right? They were monitoring the radio signals that matched the Doppler shift of the moon. They observed it happen. That's why, even though it was in their own geopolitical interest in order to tell the world that America faked it, that was to their advantage. They did not do that because their scientists and engineers verified that it did happen. Even though, if they had told everyone it was fake and they had poisoned the well, because they would have had the capability of providing evidence that it was fake, right? They're a governmental agency with scientists and engineers. They could have provided evidence if it was fake. The fact that they didn't either means that Russia and the US were secretly working together and the Cold War was one giant global conspiracy, or we really went to the moon. Which one's more likely?
All right. Next one coming in. Spanky Balls says, Flat Earth guy, how much money did it cost to build the flat Earth? That's a strange question.
Flat Earth is just reality. You can't build it. It doesn't cost money. It's observable, demonstratable. And I just have to say, my favorite speaker that's definitely going to be there if I could go was to watch David Wood. Just had to point that out.
Yes.
Yeah, definitely.
I was going to say, they're all great speakers, and I think amongst it all, I mean, I just got to do another quick shout out to Leo Filius, who's going to be the MVP, I think, of DebateCon 4. How many debates? 3, 4 debates are you doing? My goodness. And then we hope to do some debate after review at my hotel room, because we're fun like that, and maybe have a few drinks and be silly and talk about the debates. So let's carry on. LJ says, basic theory, drop the link for one non-CGI space footage video.
I don't have it offhand, but these are readily available. I mean, there's plenty of photos of the Earth taken from space if you're not a raging tinfoil conspiracy theorist.
No actual photos, just images.
Just images, okay.
All right.
Yeah, artist renditions.
Before we go into closing statements, we have one last super chat. So if you're typing out a super chat right now, we're going to cap it here. So I'm sorry if you don't get yours read. Esteban Ilbaca says, Flatzoid, don't lie. Not accounting for Coriolis because planes can correct course is not the same as flight dynamics not accounting for it. Coriolis only requires one frame. Physics disagrees with you. Sorry, I kind of butchered that one, so I'll run through it really quick. Flatzoid, don't lie. Not accounting for Coriolis because planets can correct course is not the same as flight dynamics not accounting for it. Coriolis only requires one frame. Physics disagrees with you. So, thoughts on that before closing statements? You're on mute. Here, I'll take you. I'll ask you to come off there.
Yeah, sorry, I was trying to look for the Coriolis effect explanation. But yeah, it requires two reference frames. The fact that he thinks it only requires one shows he's just saying nah and being ignorant. And if he wants to prove it, I suggest he go and explain to everybody in history how Coriolis only requires one reference frame.
All right.
It's a common fact. Learned it in physics class. You're just hilariously mistaken. People are trying to provide you with the actual information here, but you're just doubling down in your Dunning-Kruger and saying, no, actually, I'm right and physics is wrong.
All right. Last word to you there, Flatzoid.
I can get you actual citations if you want it. Would you like that?
I would like that. Frantically Googling.
No, I'm trying to get it on screen for you. Let's see if I can quickly share my screen. And then I would like an apology from you. How's that? In physics, the Coriolis force is an inertial or fictitious force that acts upon an object in motion within a frame of reference that rotates with respect to an inertial frame. 2 frames.
Yeah, but you only need to do
2 frames.
You only need your calculations in one coordinate system, right?
Sorry, nobody said calculations. This is an actual effect which requires 2 reference frames. You said I am Dunning-Kruger and ignorant to the subject, but you didn't even know how to tell me what Coriolis was. So I'm asking you for an apology, please, because I got it on screen. 2 reference frames.
No, what you're reading on screen is not saying what you're concluding from it. That's the difference. You are misinterpreting what you're reading.
Cool. 2 reference frames: inertial reference frame and non-inertial. Again, the moving object is in the inertial reference frame, and you in the moving reference frame watching the apparent deviation is in the non-inertial reference frame. This has to always be with Coriolis. You require 2 reference frames.
All right.
That is not the case, sir.
Let us go into some closing statements. So 1 minute on the clock. Over to you, Grayson. Close us out on your thoughts on this discussion and where you think we're at.
Okay, so we didn't really get to hear. I mean, he tried to show demonstrations that showed how a sun sets on a flat Earth and utterly failed to demonstrate that. I'm sorry, Flatzoid. I know you think that you really did something there, but you showed a bunch of bottle caps on a board, and I didn't see any bottom-up obstruction. Again, we know it's not just an optical effect because nothing in the physics of optics can explain that, okay? It's not just some sort of diffraction or angular resolution limit. It's nothing to do with optics. We know how it works. And with the flight times, it was a complete and utter dodge. He knows that is literally just straight not possible for the Earth to be flat and for us to have the flight times that we do. Anyone can look at the flight times. The information is available to literally everyone. If you go through, you compare enough cities, you can prove for yourself that the Earth cannot possibly be flat.
All right, that's time there. All right, 1 minute on the floor. Closing thoughts, Flatzoid.
Okay, notice, guys, the only one who did show demonstrations and was able to explain everything was the flat side. The other guy just, I don't see it, nah. And also note that the Coriolis claim, he doesn't understand how Coriolis debunks the globe. Based on your globe model, the flight times between LA and Charlotte, North Carolina would have a deviation of 4 hours difference, which debunks your claim of the globe. Also note that everything I was able to demonstrate and explain on a flat Earth, which, yeah, I didn't see one demonstration from him other than nah. Thanks, guys.
All right. Well, thank you. And thanks to both of our speakers. Big round of virtual applause for both of them.